Hello, today we will be synthesizing cuprous chloride as a way to test for copper 2 plus ions. Copper is good in small quantities, however it can cause a lot of health issues when it is found beyond prescribed quantities. The government of Western Australia states that prolonged exposure to copper can cause nausea, headaches, liver damage and even death. The Indian standard for copper is 0.05 milligrams per liter of drinking water. The presence of copper will provide a positive result in the following test. We start off with a solution of a copper 2 plus compound in concentrated hydrochloric acid. It is very dark green due to the presence of the tetrachloridocuprate ion. We then add a piece of metallic copper into the test tube and boil the contents for some time. Here is the copper. We will leave it there to boil for some time. Copper reacts with 4 mole equivalents of hydrochloric acid to form tetrachloridocuprate ion and 4 hydrogen ions. Then the tetrachloridocuprate ion reacts with copper metal and hydrochloric acid, forming CuCl in chloride solution. This is called a comproportionation reaction, wherein two atoms of the same element with different oxidation states react to form two ions of the same oxidation state. So this is the equation. The liquid level keeps rising and falling due to the phenomenon called bumping, which is related to boiling. We then switch off the heat source and wait for it to cool for about 10 seconds. Meanwhile, we prepare a solution of potassium metabisulphite in a large excess of water. The potassium metabisulphite will ensure that the CuCl does not get oxidized back to CuCl2 by the atmospheric oxygen. Here I am shaking up the vial. And then we directly dump the solution that we got by boiling into the vial containing the water. Vigorously shake it and add some more water. As you can see, after it was added, the vial has turned cloudy due to the deposited CuCl and it appears as white particles floating around in the water. If you let it settle for some time, you will observe a white layer underneath the greenish or bluish liquid layer. This is the confirmatory test for copper ions in water. This is the second test. In this test, we will be taking a little bit of the solution that we have obtained as a result of the first test and diluting it with a large excess of water. This is the water. This now diluted form is almost completely colorless, and this represents how copper would look if it were present in your drinking water. So to this, we have to add solid sodium hydroxide. The solid sodium hydroxide reacts with copper chloride to form copper hydroxide and sodium chloride as shown in the above equation. Upon shaking the mixture, we get a bluish or a greenish precipitate. You can see it's a very nice pale blue color. To this, we have to add a few drops of glycerine. Upon shaking, glycerine reacts with copper hydroxide in the presence of more hydroxide ions to give a deep blue solution of copper glycerate. This is a confirmatory test for copper ions that can be used to test for copper in drinking water, because this can only be done when copper is at low concentrations. So in summary, we have used two tests to finally prove the presence of copper in drinking water. Thank you for watching.